Alright, if you are watching this video, then it means you did not understand the answer key to last night's worksheet. So this will go through each problem in detail, and you're welcome to fast forward through the video to see what you need to see. If I had to graph g of x equaled 4 times x minus 3 times x plus 5, the first thing I do is recognize that this is intercept form. So quickly from this information on a sketch, I could find the x and y intercepts. So, quickly I could find the x-intercepts. The x-intercept is 3, the other x-intercept is negative 5. So, how did I find those? Set this equal to 0, and I solved, and I got x equals 3, or I got x equaled negative 5. Good? After that, I know that all quadratic functions have some line of symmetry. So I would take those two values, 3 and negative 5, I'd add them together and divide by 2. That's finding the average. I'm averaging these two coordinates. I get negative 2 over 2, which is negative 1, and that tells me that at a value of x equals negative 1, is the axis of symmetry. So I know that that's the axis of symmetry. I can now plug this in for x into the function to find the y coordinate of the vertex. G of negative 1, I get 4 times negative 1 minus 3, which is negative 4, times negative 1 plus 5, which is positive 4. 4 times negative 4 times 4 is negative 64. Not the greatest function or value here, so I'm just going to approximate it down here, and I'm going to say that that's negative 64. Graph obviously not to scale. Alright, so now I have the vertex if I needed that. The vertex is the point. Negative 1 comma negative 64. Another important point with any quadratic would be the y-intercept. Really any function if you can find a y-intercept. That's g of 0. So to find g of 0, I plug in 0 and I get 4 times negative 3 times positive 5. That's negative 15 times 4, or 20 times negative 3. Either way, you get negative 60. That would be up here, obviously above negative 64. So now I do my best to sketch that graph. Yikes. Unfortunately, I can't just undo that. I wish I could. Yeah, so not the greatest picture, but don't forget to label your axes, and hopefully you can see all the important information from there. That's a review of working with intercept form. All right. How would you graph this function? Well, recognize that it's in general form. So, the x-coordinate of the vertex comes from the negative b over 2a. That is related to the quadratic formula, which we'll get to in the next video. So I plug in the values, and I get negative 6 over 2 times 1. That gives me positive 6 over 2, and that gives me a value of 3. I now need to find the y-coordinate by plugging in 3. I get 3 squared minus 6 times 3 plus 4. I get 9 minus 18 plus 4, which is 13 minus 18, or negative 5. The y-intercept, if I needed to find that, the y-intercept would be 4. Just the constant in the original form there when you're dealing with general form. So already I have enough information to graph. So to graph this function, I would go to the vertex, which is at 3, negative 5. 1, 2, 3, and down 1, 2, 3, 4, 5, and that's right there. I would graph the y-intercept of 4, 1, 2, 3, 4, right there. And now I would use the statement of symmetry, this idea of symmetry, that all quadratics have an axis of symmetry. So if this point here is 3 away, I can walk 3 on this side and I can plot the same point. You're welcome to plug in a value of 6 here and see that it works out to 36 minus 36 plus 4, which ends up being 0 plus 4, or 4. Now that's enough information to graph, but there's your x-axis, there's your y-axis. I would also love for you to be able to find the x-intercepts. So if I draw this function right here, try to do a better job. It hits that point, back up, and there. I'm much better by hand than I am with this computer device. So there's two x-intercepts right here, and to find their value I would just solve the equation when f of x equals 0, or right here. At this point there are no factors of 4 that add to 6, so you would have to complete the square to solve this, or if you remember that the quadratic formula would work in this case, you can do that. But remember, and you'll see in the next video, that the quadratic formula is not magic. It is simply completing the square on a general quadratic. So let's just use the quadratic formula for ease. X is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c. That whole mess gets divided by 2 times a. I simplified as I went along. That's 6 plus or minus the square root of 20 over 2. At this level, you need to know that that's 6 plus or minus 2 root 5 over 2, and that simplifies to 3 plus or minus root 5. Square root of 5 is smaller than 3, so you can see right here, here is the value 3 minus root 5, just a little bit bigger than 1 or 0, between 0 and 1, and here's the value 3 plus the square root of 5. You can see that fits with the graph. For this function, you recognize that it's in vertex form, which I love because it's the easiest to graph from. So I'm actually going to graph straight from this form. I identify h and k. H is negative 4 and k is positive 3. So for this, I would start somewhere like this, and I would go back 1, 2, 3, 4, and I would go up 1, 2, 3. That would be my new 0, 0. Putting in dotted line axes here, kind of fake axes. From HK, all I have to graph, this is the beauty of understanding transformations, this is x, this is y. I have to just graph y equals negative 1/2 x squared. So if I plugged in 1, I would go down 1/2, and if I plugged in negative 1, I would go down 1/2. If I plugged in 2, 2 squared is 4, 4 times the negative 1/2, that's down 2. If I plugged in negative 2, that's positive 4, but times negative 1/2, that's negative 2. And so I get this wider looking shape. Good? Now, harder to find the important information. Axis of symmetry was pretty easy. It's the line x equals negative 4. But if I wanted to find these intercepts, I would set this equal to 0 and solve. If I wanted to find the y-intercept, I would plug in a 0 for x. Let's do both. So if we wanted to find the y-intercept, h of 0, that would be negative 1/2 times 4 squared plus 3. That's equal to 16 times negative 1/2. That's negative 8 plus 3, and that's negative 5. So that value right there must be negative 5. Now I want to find the x-intercepts. It's actually really easy because you say 0 equals negative 1/2 x plus 4 in parentheses squared minus 3. Because what you're trying to solve for is inside this parenthesis and it's squared, we can add 3 to both sides and get 3 equals, I think I wrote this down wrong, sorry, that's a plus, so subtract 3 from both sides, get negative 3 equals negative 1/2 times x plus 4 quantity squared, multiply both sides by 2, I now have 6 equals x plus 4 quantity squared. Take the square root of both sides. Get plus or minus the square root of 6 equals x plus 4. Subtract the 4 and you get negative 4 plus or minus the square root of 6, which equals x. There they are. There's negative 4 minus the square root of 6. There's negative 4 plus the square root of 6. Interesting. Notice that this value is negative 4 right here. See how I'm adding root 6 and I'm subtracting root 6? It's not a coincidence. It's connected to the graph. Okay. The last one for this video, and then just because it's getting long, how would you graph this function? So again, we are noticing forms. In this case, general form. So negative b over 2a, in this case, that is 3, negative 3, right? The opposite of negative 3 over 2 times a half, which is 1, and that ends up being 3. Now we find f of 3. That is 1/2 times 9 minus 9 plus 2. 1/2 times 9 is 9/2. 9/2 minus 9 is negative 9/2. Add 2. And then that is equal to negative 5/2 because 2 is 4/2. Good? So now I know the vertex. From there, I can graph the function y equals 1/2 x squared. So I could start this function by going over 1, 2, 3, and going down 2.5. Treating that like it's my new HK, putting in some dotted line axes. Even easier than going from that as a vertex, this is x, this is y, is I could use the y-intercept, which is 2. If the y-intercept is 2, symmetry is your friend. I can go this way 3 and up 2, or I can go this way 3 and up 2. And now I have a beautiful graph with enough points. I have the y-intercept. I can see the axis of symmetry. But again, if you want to be able to find the x-intercepts, you should know the quadratic formula. In this case, 0 equals 1/2 x squared minus 3x plus 2. We can just go with it like that. X equals 3 plus or minus the square root of negative 3 squared, which is 9, minus 4 times a, that's 2. 2 times 2 is 4, all divided by 2 times a half, which is 1. Simplify this and you get 3 plus or minus the square root of 5, all divided by 1. 3 plus the square root of 5, 3 minus the square root of 5. Good? There they are. 3 plus root 5, 3 minus root 5. The next video is about rewriting those functions.